Alright guys, today we're going to talk about covalent bonding. So we should have read about it a little bit, got a little bit of practice with it. So in a covalent bond, atoms blank one or more electrons. So we talked about ionic bond, they give and take electrons to form charges. Well here you can think of atoms are going to basically share electrons. And you could argue that they're not really sharing it, they're fighting for the same electrons, trying to pull on the same electrons, and that's what's going to hold them together. But these electrons are going back and forth between the two atoms that they're bonding together in the covalent bond. So each atom is left with, again, a full outer shell or energy level. So usually this is going to be 8 valence electrons, unless we're talking about like the first energy level, then we're dealing with 2 valence electrons there. All right, a covalent bond forms between 2 blank. You gotta ask yourself, what wants the electrons? What's close to having a full energy level and they just want, 1 or 2 or 3 more electrons? They should always be the non-metals. All right, so we're gonna try some examples and show what we're talking about here. All right. So we have hydrogen and hydrogen, so meaning we have 2 atoms of hydrogen. We're going to start off the same way we did with the ionic bonds. I'm going to draw the electron dot diagram. Alright. Now, instead of drawing an arrow to transfer electrons, we're actually going to circle the electrons they're going to be sharing. So this is one shared pair. And what this circle means is that these 2 valence electrons, sometimes they're over here by hydrogen, keeping that hydrogen happy because it has a full outer energy level of 2. And sometimes these 2 electrons are going to be over by this hydrogen, making it happy as well. So a lot of times, instead of, once we get more practice with this and we start to see it, we won't have to draw the dots out each time. You're just going to see basically a dashed line connecting this. And that dashed line over there basically means that they're sharing 2 electrons. So a dashed line equals a shared pair of electrons there. Alright, and the last thing I want you to do with these problems is write the chemical formula. So for this one, we're going to have H2. So again, this is a subscript saying we have 2 atoms of hydrogen. There's no other atoms involved, so it's just H2 for our chemical formula. All right, let's try 2 hydrogen and 1 oxygen, aka water. All right, so if we draw this, oxygen, 1 atom, we know valence electrons, find the periodic table. It's in group 16, so it's going to have 6 valence electrons. All right, then we draw our hydrogen. Each hydrogen has 1 valence electron. And right now, oxygen has 1, 2, 3, 4, 5, 6. We know it wants to get to 8, and it's going to get to 8 by sharing electrons here. So this one can share. So this hydrogen's happy because it has 1, 2 valence electrons. Now I can count my oxygen. I have 1, 2, 3, 4, 5, 6, 7. So it needs 1 more electron, or at least share 1 more electron. So if I circle this pair, now when I count the oxygen, I have 1, 2, 3, 4, 5, 6, 7, 8. This hydrogen is also happy because it has 1, 2, filling its first energy level. So again, we can write this as this oxygen is going to share 1 pair of electrons with this hydrogen over here. And it's going to share 1 pair of electrons with this hydrogen over here. All right, so our formula, we have 2 nonmetals, so we tend to write the one farthest to the left first. So in this case, hydrogen is farther to the left on the periodic table, so we're going to write H2O, which is good old-fashioned water. All right, we'll try a couple other ones. All right, so here we have chlorine and chlorine. So again, draw the electron dot diagram. It's in group 17, so there's 7 valence electrons. So I'm going to just draw 2 atoms. Each have 7 valence electron. So they each need 1 more in order to be happy or stable. So we're going to share this 1 pair of electrons. So again, we can write it with a dash to show 1 shared pair, and the formula is just Cl2. All right, this next one, we have 2 oxygen atoms. Again, we know 6 valence electrons are going to be for oxygen because it's in group 16. All right, they have 6. We know they want to get to that magic number 8, so they're going to have to share 2 pairs. So if I circle 1 pair, I circle another one. Each time you circle a pair, you will never circle more than 2 valence electrons with 1 circle. So now I can count this out, make sure they're happy at 8. 1, 2, 3, 4, 5, 6, 7, 8. I go to count this one. 1, 2, 3, 4, 5, 6, 7, 8. Now to show this, this is what we call a double bond, so it's stronger than a single bond. So we have 2 dashed lines showing that there's 2 pairs of electrons being shared between those 2 oxygen atoms. Chemical formula is just O2. All right, example 5. We have carbon and we have 2 oxygen. So carbon is in group 14. So we know it's going to have 4 valence electrons. Oxygen, we've had plenty of examples, so we know by this time it has 6 valence electrons. So really you can start anywhere you want as long as at the end all atoms involved are happy. So I'm going to start over here at the left. 6 valence electrons, so I know it's going to want to share 2 pairs. So I'm going to circle 1, I'm going to circle 2. So I can count 1, 2, 3, 4, 5, 6, 7, 8. This oxygen's happy. Now I'm going to look at this carbon. It has 1, 2, 3, 4, 5, 6. So it wants 2 more electrons. Well, I know this oxygen is also going to want 2 more electrons, or to share 2 more electrons. So I'm going to circle that. 2 more pairs. So again, check this carbon. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So in this case, I'm going to have an oxygen. I'm going to have a double bond between this oxygen and this carbon, and a double bond with another oxygen and that carbon. Our formula we get is CO2. So we got carbon dioxide there. All right, last one. We have carbon and 4 hydrogen. So maybe you can give this one a try. Pause this and try it on your own and see if you can get it correct. So we have carbon with 4 valence electrons. I have hydrogen with 1 valence electron each. So I know hydrogen, because it only has 1 energy level, to fill that one up, it only needs 2 valence electrons. So in this case, if each one of these share a pair, each hydrogen has 1, 2. This hydrogen has 1, 2, 1, 2, 1, 2. And then if I count the carbon, I have 1, 2, 3, 4, 5, 6, 7, 8. So if I draw this with the dashes, again, these are all single bonds. So a dash with a hydrogen, a dash with a hydrogen, and this one's, it's gonna defy the rule. Usually you write the left one first, so I would accept the H4C, but a lot of times you'll see this written as CH4. So I would accept either one in this case, kind of exception to the rule. So that's drawing covalent bonds there. Types of covalent bonds, so the book talked about this a little bit. We have polar, which are stronger. So that means one atom is going to have a stronger pull. So most of the time they're going to be spending closer to one atom. And what this does, it involves a partial charge. So it's kind of similar to the ionic bonds where we have a positive one and a negative one. Well, in this case, because the electrons are, whichever one they're spending more time closer to, it's going to have a partial negative charge. The other ones are going to have a partial positive charge. And the reason why you ever tried like the penny drops, water drops on a penny, that surface tension, it goes back to because it's a polar covalent bond. The water molecules are partially charged and they're attracted to each other, and that's what's going to hold them on. Now, non-polar, these are going to be equal sharing of electrons. A lot of times you'll see this if we have the exact same element. So like O2 or H2, because we have two of the exact same elements pulling and they have the equal strength pulling in both directions. But over here we have H2O, right? And the oxygen is going to have a stronger pull of those electrons. So it's going to get that partial negative charge there. All right, that'll wrap it up for covalent bonds.